Folks, our next presentation is a case study by Cochran, Vice President of Conformant. It's the world's largest MBT deployment transforms testing for quality at agile speed. Let me introduce Clark to you. So Clark comes with about 35 years of highly successful experience in advanced technology products. He's worked with various companies in sales management positions. And folks, please help me welcome Clark Cochran.
Can everybody hear me in the back? Dynamite. Okay, I want to thank UAI. I want to thank Pradeep for asking me to talk today. I think it's a very interesting opportunity to have us look a little differently at testing. I heard some very good talks this morning and a lot of good information. But the one thing that struck me as I was listening was we were still talking fundamentally manual. And I know people have to be involved, but we were still talking about manual processes, manual thinking. We needed to manually think of the test scenarios. We needed to manually think of what we were going to test or the data. We had to manually think about executing, or if we were going to automate, we had to manually write those scripts. So we're doing a lot of manual, but we're trying to improve the process to make it faster. And because there's so much work to be done, frankly, the issue is that we have to look at kind of a risk-based testing approach, which opens up quality issues because you don't have enough time to do everything. So again, we're still basing everything on manual. We're just trying to improve it. And that gets really, really hard when we add Agile into the mix. Why? Because everything's compressed. And we hear stories about TDD, BDD as being a methodology to do that. Frankly, those come from an Agile manifesto 15 years ago. And you don't have anything in your electronics that's 15 years old. The issue is one that they don't think about what can be because it's an older process thought. The problem is not so much in that process, but if we think about it for a minute, if the developers are doing testing, that takes away the efficiency. I work a lot with testing service providers. Are they going to go to their customer and say, I'm going to increase your testing rate card by 30% because I need to use a developer? Won't fly. Another big flaw in that is that every tester, every developer that's doing testing is going to test his or her own component. So you have silos. When do they test the system working together? When do they integrate that test? A month later? 2 months later? That's not continuous integration. That's just passing the problem down to the tester in the same way we do it today. So that's not the right way to go, at least in my mind. And then we have the issue of cost, and that's big, and we've heard it. And the issue in cost is, from the U.S., there was a big push to reduce testing costs, improve profitability. Indian service providers stepped in. Let's reduce that cost because we can leverage lower cost testers that have high quality. Well, 30% offshore, 70% onshore. Okay, great. Then a few years later, U.S. came back and said, reduce costs again. So they flipped those numbers and they said, we'll put 70% offshore. Well, I'll tell you right now, I know that service providers in this audience are saying, the U.S. companies are coming back again and saying, reduce costs again. Cut by 30%. How do you cut by 30% and still stay profitable? You put freshers on, what does that do to your quality? So they're under extreme pressure to reduce costs. And if you think about everything, the philosophy of testing, and you base it on manual, it's very hard to make that next step. So what I think we think about, if I use an analogy for a minute, real simple. If we talk about manual testing, it's like a manual steering wheel in a car. Everything's done by the driver. If we think about helping with automation, it's more like power steering. The driver is still doing it, but it's just easier, it's faster. That's not going to be enough. What you need now is something that takes the next step. That's like a Google car. You tell it where you want to go, and it does everything. And you may not see too many Google cars in Bangalore, but I'll tell you, in Silicon Valley, they're everywhere. They're real. And so what we have to think about is, what can we do to fundamentally take that next step, that next generation of testing? And I'm here to talk about model-based testing. I mean, model-based testing is real enough that ISTQB has now released a training course, a foundation-level training course in MBT. The idea here is that it's real, but people still come and say, well, you know, MBT, it's not real. It's not able to handle big projects. It's not able to handle something at my scale. And that's what I want to talk about today. Because that's baloney. It does, it has, and I'll talk about it. So, I want to give a little situation background, and we'll get into more of the details. This is a big company. It's a big telecommunication services company. It doesn't really matter about the vertical market. It's just an example of a customer that's done its very large deployment. We're talking about homegrown applications. Could have been COTS tools, but this is what they were testing. They had many, many different individual applications that needed to be tested. It really runs their entire business-to-business operation. So it's critical. You know, quality is built into that. And I really think that in general, and this is a separate topic, I don't think we really define quality well enough. Good enough? What is good enough? If I'm in an airplane, I want to know that it's 100%. Other things may not be as important, but we need to know what quality is. And so the issue is you have to understand quality, and really the idea is that you need to be able to know what you're testing, you need to be able to know what you've covered, you need to have known quality. And they were doing a whole variety of different types of testing. They were testing through the UI, but they had the back office software. They did some headless monitoring software, end-to-end application testing, and they needed to work in their SDLC environment. They needed to make the tools all work that they'd already invested lots of money to use. But they wanted to glue it together, and they wanted to automate everything. Don't just manually connect the dots. Connect it in an automated way. So what they had done today is it was fundamentally like we talk about. It was manual with some automated assistance. The defect slip-through was too high, and it wasn't fast enough. Because as Jay said, time to market is everything. If you're not there first, your customer is, and that's a huge hit. So you have to get there faster, and that's what they wanted to change. So what did they need to solve? They needed to solve that deployment time. How do they get there faster? But they had to do it with quality. And so the issue is, how do they keep their tool chain? How do they make this change? Because if you do it in a little piece here and a little piece there, it's easy to make that decision, but it certainly doesn't impact you as much as if you could actually decide to move forward together. And so they actually looked at this and said, we want to make this change. Corporate level, we are going to change our process. What do we have to do? And all of a sudden, everybody started to get concerned. Everybody raised questions. Everybody started to worry about stuff. So what did they get concerned about? They would have had a few different concerns if they were doing all their testing internally. Some was done internally, but a lot of it was outsourced. So the issue then became, could their service provider deliver these capabilities? Were they at risk because they were going to make a change that couldn't be delivered by their partner? And Could it be done fast enough? Because they wanted to move from a traditional waterfall into, I don't want to call it Agile, I'll call it kind of an iterative release, but it's an Agile concept. Could it be done fast enough? Or are they going to set themselves up for failure? And could, at this level of transformation, could their testing service provider deliver it? So lots of issues that they had that they worked through. But then there was the level of, can MBT even do it? Is it capable enough? Many of you have seen MBT in the past. Today's MBT isn't the same as yesterday's MBT. True with many things. But they weren't sure it was capable enough. There was a big issue there. And could they find an MBT tool that actually did everything they needed? And so there was a lot of issues, the same kind of questions that you'd be going through if you were doing this transformation. And so what they wanted to do is they wanted to look at the goals and understand what they were trying to achieve so they actually could measure that they could achieve that. And so speed. And I was talking to a Forrester analyst, and his tagline was quality at speed. That's nice, but that's not enough. You need adjectives. You need to have known quality. What is the definition of quality? You need to set that. You need to know what it is. You need to know what you've tested, what you haven't tested. What did you miss? And you need to do it with speed. Speed is relative. You need to do it at the speed that you need, and simply said, at speed of development. So you need to look at that, and then you need to look at reducing your cost. Because if everything is still going to be people-based, you're still going to have that issue of cost. So how do you actually then wrap those three aspects together and come up with a process, a new testing program to deliver that? And so the executive management realized there was a big issue. They drove it from top down. You're not going to make change from bottom up. That's all incremental. They were looking at a much bigger transformation. So, trigger finger. So the idea is they had to start changing this thinking process from resources, from people, from body count centric, to thinking about technology and how they could leverage the technology. So they flipped that thinking process around. And of course, they looked at the industry and they said, okay, what are all the tools out there? How can we look at different pieces? How can we fit them together? What's the right thing? What do we need to hit our target goal? And they had a lot of capabilities they came up with, and I'm just kind of going to get out of the way of the screen and say that they needed to be able to test all aspects of their system. It's not enough to just test through the GUI. You have the back end that you need to test. You have the APIs that you need to test between the applications themselves. You need to be able to integrate into the SDLC tool chain that they had already. You need to test fast enough. You don't want to just test and then manually do execution or manually write scripts. So they wanted to automate the generation of scripts or automated execution. They wanted to know what they've covered. They wanted to visually see what in my application have I tested and what have I missed. They wanted to validate that every one of their requirements that they had for their application was covered. What tests covered, what requirements. That way they could actually then map back and say, I have quality, I have known quality because I know what I've covered and I know I've covered these requirements and how I've done it. And then of course everybody has their own reporting system. There isn't just two projects in the world that have the same reporting formats. They all had to be different, even though they wanted consistency, but every project was slightly different. And so these were the things that they looked at a high level for what was important to them and what they wanted to focus on. After going through that and doing extensive evaluations, you know, their TCOE teams came back and they said model-based testing was what they wanted to try, what they wanted to target as their next generation of solution. So how'd they go about this? They had multiple testers, multiple locations, everybody had to be convinced. They ran 9 separate proofs of concept. Each one was looking at different capabilities, so they weren't all structured to be the same. So they were actually very effectively spread to cover all the different types of aspects and the different types of applications and the different concerns that they had. And then they went through and they had measured how much time it took today, what the quality was, all the details, so they could do a quantitative comparison of today versus what this would mean going forward. And obviously they needed something that could handle the complexity, because there's a lot of information, a lot of details. It had to work. It couldn't be a simple tool. It had to be technically capable. And automate. They wanted to automate everything. If I've got one SDLC tool in the chain, let's say it's a requirements management tool, I want to map it straight into the MBT tool. If I have test case management, I want it to automatically integrate. If I have an automated execution environment, I wanted it to just send the scripts in and have it executed. They wanted to link everything together in an automated way. Why? Get rid of those manual roadblocks that are in between so you can speed things up. And selected Conformant, and so what happened first year? It's been a 3-year program now, and it's accelerated. There's a lot more benefits that have come. But I thought for this audience, the best thing to do is show you what happened the first year, so you have an understanding of what you could achieve year one. And after that, it obviously gets better. So what happened that first year? They had 100 Conformant licenses, and 250 users were trained. That's not a small project. 7 cities, 2 countries. Took 10 months to get it fully deployed. You're not going to pop out of the box and have everybody running. So there was a structured program set in place to pick the projects, to select the people, to set the training programs, to train the trainers, to deliver the services. So everything was set up to run as a process. So during that first year, they did 40 projects, which is a combination of applications and the end-to-end testing of multiple projects together. They counted those separately. Of that, the applications were 25. Okay, and these aren't simple applications. They developed 550 models, and clearly there were fewer models in the beginning and more toward the end. And in fact, just to give you an idea, there's another project. It's a banking project, but they did their first release, and they used MBT, and they got the same kind of efficiency gains we're talking here. But then we looked into what they got the second year, what they got when they were able to reuse those models on the next project, or just modify them to use them on the next iteration. And they got an 80% improvement, 20% of the effort that they previously had. And they generated over 12,000 test cases. What were the results? They're using an Agile type process. It's a monthly release cycle. They can actually do progression testing. What are we talking about? We're talking in-sprint testing. And I'm not talking about manual testing. These are automated execution. Not every test can be automated. Manual testing is still going to be needed. But of the tests that could be automated, over 95% were, straight out of the box. 37% overall productivity gain in progression testing, and then the overall cycle, which even went into the execution, was also improved. So 1/3 of their cost, 1/3 of their manpower, 1/3 of their effort and time, and all is gone. So the interesting things were additional information. They were able to improve their test design. They were able to improve their execution coverage. They were able to get consistency, which was interesting. We hadn't even thought about this. They said because in manual testing, every tester writes a different type of test, and we have to understand what he really means by that, and so it takes us longer to validate those test cases. Well, here, they're all consistent. So it's much easier for us to understand if this is covering what we need. They integrated into their tool chain, and It solved the need for known quality at the speed of development. Some of the deployment learnings, because I think the issue here is not just, hey, it happened, but what did they learn from it? What can you learn from it? What do you need to know going into a project like this? They were working with their testing partner. I'll just say that partner, it was Tech Mahindra. But they had to go back with their testing partner, and they had to change the commercials of that engagement. Why? Because what testing partner is going to go in and say, sure, we'll change over to a new process that's going to improve the quality and improve the time to market, reduce your costs, and they're going to say, oh, great, we'll pay you 1/3 less money. There's nobody that's going to do that. So they had to go back and they had to change from a time and materials basis. They had to go into a managed service or a fixed price, cost plus. They had to go to something that incented the service provider to improve the methodology to that customer. It did, but that's needed in when you engage. You have to be thinking about that. You can't just force somebody to change, and it won't be effective. And some of the things that were learned in the deployment, and I heard it earlier, testers and developers need to work together. Now, the interesting thing in this with model-based testing is the testers actually create, or an SME, creates a model. It's like a Visio diagram of the way the system's supposed to work. That might be looked on as an extra effort, but there's a report that was done by University of Southern California that said just modeling the way the system works and seeing it can reduce defects by 50%. We were on a very tight Agile project at Fannie Mae in the U.S. where every 2 weeks they had a sprint, 2 sprints to a code drop. We could model the system fast enough so the developers could see if they understood the spec properly. Because the developers, what spec is really fully understandable? There's omissions, there's ambiguities. Well, what they did here was they could visually see it, they could see if there were missing things, and that made the developers actually be able to code much faster. So guess what? At that point, all the test cases were ready, because the way MBT works is you press a button and you have your test cases. So as soon as they were ready with their incremental code, it could be tested in an automated execution. So the idea is that you need to have your rollout, you need to have your support, you need to be expecting that there's going to be change resistance, because everybody is kind of opposed to change. Hopefully not management, because that's their job, is to drive change. Reuse that I mentioned earlier, that's not something that just pops out. It's like when you program, you can program for reuse. When you're modeling, you can model for reuse. And people initially say, oh, modeling, that's complicated. That's a lot of thinking that I don't have. Well, this gentleman, Thomas Hirsch, was not involved. But his basic premise, his position, we're late. Yes. Okay. Yeah. Yes. We can talk about that. Actually, we have our director of development on our Bangalore test center here, and he can talk very specifically. Kalyan, raise your hand. Can you see this man? And he will get into the details on that. I'm purposely avoiding the details in this presentation, or we'd be here for hours. There's a lot to talk about. But the idea is that if you can't think the way the application is going to work, you can't develop it, you can't test it. And all modeling takes is thinking. Have you used a Visio diagram? You're now thinking of the way the system works. That's fundamentally what we're talking about. But it's an excellent question. Thank you. And you're going to need support. For any major rollout like this, you're going to need team to help your team. But you also have to plan to have some extras, shadow people. Why? Because you're going to have churn. You're going to have churn in your own program. You're going to have churn if you're using a testing provider. And you can't have an impact if you're doing an Agile type product release to have a guy walk off the project and have to replace him by somebody that doesn't know what's going on. So you have to be thinking about that. And you need best practices, because this does change the way the testing process works. So you need to explain what that impact is, and it needs to be adopted by the team. couple more slides here. Some of the things they looked at is they did not want a proprietary tool. They did not want a tool from a vendor that locked out everyone else. Everybody uses multiple service providers, so they needed to have a level playing field. Not all tools were equal when they reviewed those. Most all tools, in fact, all tools except Conformant, frankly, you have to think of the scenarios. And then the tool will generate test cases to test those scenarios. And you can use risk-based testing to decide how much of that you test. But that's not the way Conformant works. Conformant says you model the system. You use your Visio diagram to model the way the system works, and the tool thinks of every single scenario that's been modeled. Thousands of scenarios. And then it optimizes it down to the tens of test cases that cover every requirement that you had in your requirement document that was put into the model. That's the Google car. I don't think of those things. I let the tool think of those things. Now I look at it to validate it, because maybe I did a wrong model. Let the tool do all the work. I'm still going to look at in my Google car, and I'm going to see if I'm going in the right direction. But I'm not going to steer. I'm not going to be thinking about the gas. I'm going to let the car do it. Here, the tool does it. That's why you can get this acceleration, and you can reduce the people, and you can do all the optimization we talked about. And the key here is to deliver known coverage. Actually, the tool shows you the path through the model that every test case covers. It shows you what every requirement that's covered by every test case. So you know what you have. Or better, you know what you've missed. Because that's what keeps you up at night if you have a mission critical, or you have a health critical, or anything that's a financial critical type application. You need to know what you've missed. And then at the end of that, once you've generated those test cases, you want to output the test scripts for automated execution. Click. So eliminate all the manual steps except one. Understand what you have for your application. Understand the way it works. And after that, it's a button press. Additional things, you needed to be able to integrate with everything. Why? Because, as we heard, there's multiple platforms, there's multiple types of testing that you want to do. You have to be able to link to everything. What you have today for a test execution platform is maybe not what you have tomorrow. There's a lot of push into open source. You may say, okay, I'm going to change QC to Jira, or I'm going to do this, that, or the other. You have to have flexibility. And remember, we're not talking about test scripts anymore. Test scripts can be replaced with a button click. 10 minutes from now, I can have new scripts for everything. So I don't need to manage scripts. I manage the model. By the way, every time you make a change to that model, the tool automatically gives you an impact analysis that says these tests are no longer valid, these are new, these are unchanged. Why does that matter? Don't carry all the no longer useful test cases through to your regression pack. I was told by major customer that up to 40% of a regression pack over multiple iterations is no longer useful. But nobody touches a regression pack because nobody knows what every test covers. A director of testing for another major global company came to me. I have 30,000 test cases. I don't know what any of them do. This is an artifact of yesterday's process, not MBT process. You know everything and what covers everything. It's all documented. It's all automatically documented, even the reporting in any language. So all this information needs to be understood. And you need to align with your vendors and your partners so that you see the roadmap as you move forward and you can work together. And obviously, the bigger the purchasing you can make, the more benefit you get from cost reduction. So, couple things here. How can MBT be faster than manual design? Frankly, you say, I have to add modeling. How can I be faster if I add a step? Why? Because this is what MBT does. It automatically designs and optimizes the test cases. It determines full coverage. It writes the executable scripts. It determines the correct results. It maintains traceability to requirements. It writes and updates your test documentation. It does impact analysis and connects everything together. You take those off the table. That's a button click. So, the end of this, MBT is the basis of a major testing transformation moving forward. MBT is real. Basically, you press a button and you get what you need from this process. And that quote was told to me directly by somebody who understood that this was conceptually the same process that transformed the electronics industry. 25 years ago, everybody did circuit design by hand. Now you write a model, you press a button, it synthesizes the logic and fabricates. What we're talking in testing is you write a model, you press a button, it synthesizes your test cases for automated execution. This is the future, and it's real. So thank you.
All right, thanks a lot, Clark. Thanks for that presentation. Unfortunately, we do not have time for question and answer, so if you have any questions, you can catch Clark during the coffee break or anyone from his team, and they will be able to answer your questions. Just before we break for coffee, we just want to have all the speakers on stage. If I could ask Ajay, Tal, and Clark to come on stage, we have a few mementos that we'd like to give out.
Krishnamurthy is here, and is Arjun here? Anyway, Kalyan and Krishnamurthy are here, and if you would, seek them out equal to me to ask questions. I apologize for running over.
If I could ask Prabhu Mutt from Ericsson to come and help us hand over the trophies, please. Mr. Ajay Chokra. Dal from Experience. Dal from Experience. And Clark from Conformant.
All right, thank you. Thank you very much.
Right, thank you very much, folks. We're going to break for a tea and coffee break just now for about 15 minutes. So we'll gather back in this in parallel tracks starting from 11:10. So please make sure that we adhere to timing. Everything's going to go as scheduled. So 11:10 we'll be starting the parallel tracks. Thank you.